question which involves a circle. Certainly there'll be one, either a circle, an ellipse, a hyperbola. So you need to know those, and we'll get to the ellipses and all later. This is a circle question. A circle question, basically comes down to Pythagorean theorem, believe it or not. Let's take it for example, if I have a coordinate system here, and I'm going to do Pythagorean theorem, okay? Well, if this is my triangle, I'll do that in red. If this is my triangle, right triangle, and that is x and that is y, that is what I'm going to call r, which is I know it's the hypotenuse, but if I keep this up, it becomes, as I go around, it becomes the radius of my circle. So x squared plus y squared equals r squared defines, if you were to plug in all your x's and y's, if the center is at 0, 0, would define a circle. If I have a 3, 4, 5, if x is 3, y is 4, then I know r is 5. If I have a 3, 4, 5, that'd be my first point of my circle, but I can keep that r going, that 5 going all the way around, and I would continue to have, if I kept this up, I could continue to find my x's and y's to make that, find that r, then I would have a different x and y, but they would still be related by Pythagorean theorem. If I use that r down there, I'm going to have a negative but a very small x and a very relatively long r, okay, approaching 5. When I get to 0 coming over here, my y will be 0, my x will be 5. Here, of course, my x is 0, my y is 5. So there's a lot of things involved in this circle, but it basically comes down to Pythagorean theorem. Well, that is the simplest possible equation for a circle. So always remember Pythagorean theorem when you come to a circle question. What they do is they offset the center, so it's not at 0, 0. Now whenever I do that, like for instance, if I have, forget this for now, but if I have x minus 1 squared plus y squared equals 0, equals my r squared, equals, let's erase that, equals r squared. That's the equation. Well, it's just like what I did up here, only now I've shifted it. In other words, I want to get it back to 0. And so I've essentially shifted this whole thing over, so now the center is here, and I'm going to do this whole thing again. So that minus 1 gets it back to 0. So I know that my center, in this case, would be 1, 0. 1 over 0 up. But it would still work out to be a circle, and if you have time and you're one of these kind of people, you can go through and do a few of these functions, and you'll see you always get a circle. Alright, if I shift it to the y, I'm going to have to subtract whatever I shifted it by to get it back to 0, 0. So here we go to this problem then, well in general then, taking that information, and this is on your memorization sheet. In general we have x minus a squared plus y minus b squared equals r squared. So it's like Pythagorean theorem on steroids, and if you keep going around and around with your r, keeping your r constant, varying you remember your r must be constant, your constant radius, varying your x and your y, you'll see that if I plug a particular x in, I'll get a y, I'll get some y that goes with that. If it's undefined, then it's not on my circle. Okay, so it has to get to go and find it. But this in general then is the equation for a circle, where, okay, this is where the center point is AB. Okay, if AB is the center, then that's the equation for a circle, and R is the radius. So, knowing that information, it says in the standard xy coordinate plane, there is only one circle centered at the point -1, 4. Well, there's my A and my B. A is -1, B is 4. That also passes through the point 7, -2. Now this will allow me to get my R. Okay. Now maybe I can get lucky and I don't have to worry about that because it'll self-destruct by the time I get to the R. Meaning that I'll find the answer before I have to worry with the R. Which the following is an equation for that circle? Well, I know it's going to have to be x minus a minus 1 or x plus 1 and y minus 4. Now the ACT committee is in a bind here. Their hands are tied. They can only give me 5 choices. So I'm going to go and see if I can knock out some of these. Well, look at that. In one fell swoop, that one's gone, and that one's gone. Unfortunately, these two remain, and those two look good. Well, now all I got to do is find out which one. Well, I could pretty much tell you, but I'll quickly sketch it out. It looks like because it's got to be squared, right? And they're not going to give you some weird square root of 10. So if I was in a hurry, B's my answer, I'm moving on. So I'm assuming my R is going to be 10. Let's take a look. If it's -1 over 4 up, puts you right there. It's going to have a point on it that's 7 over -2 down. Certainly I'm looking at B as my answer now. This length is going to be 10. I can almost guarantee it. Well, you can go ahead and just to prove that to yourself, you can do the old Pythagorean theorem. You know that distance formula? It's only Pythagorean's theorem. That's all it is. They keep trying to give you new formulas when it's the same formula over and over again. Why not teach one formula and show all the application rather than confuse the student by teaching them the equation for a circle, the distance formula, all this kind of stuff. So look, if I want to know I want to make sure, I'm just going to verify. I would have been gone by now. I'm on the next 2 or 3 problems. But if you want to go back and you have time, you want to prove that that is 10, you may want to circle this problem and say, okay, I'm 90% sure it's B, I'm moving on. Let's go ahead and take a look. If that's going to be -1, 4, and that is 7 over and -2 down. Well, it was at 4, that's at -2, therefore that length is 6, right? Because that was 4 up and 2 down. This length here is -1 over 7, so that's 8. Well, there I got it, because remember the mantra. You have to know those 3 right triangles. 3, 4, 5 is one of the most common right triangles on the ACT. Okay? 5, 12, 13 is also a big one. But 3, 4, 5, there it is. 3, 4, 5, just a multiple of it. And so that verified what we already kind of knew. B is the answer. Okay? So watch out for a circle question. And if you watch these, if you don't mind emailing me, daskeemac@mac.com. It's on the literature, but daskeemac@mac.com. Let me know if this is helping. I'll continue to do it if I get encouragement. All right. So thank you, and good luck.